Let's talk about the things that hold molecules together. Bonds, but not James Bond. We're talking about chemical bonds. A chemical bond is an attractive force that is between atoms or ions that binds them together as a unit. It's a connection. Atoms which are bonded together will form compounds. The reason the bonds form is because of stability. They want to achieve that noble gas configuration, that happy atom status. They want all of the orbitals in their valence electrons of their valence shell filled with electrons. So they bond together, and they can either give and take with electrons, or they can share them. It just kind of depends on their electronegativity and the radius of the atom and ionization energy, things like that. But basically what happens is you've got a nucleus here and a nucleus here, and the electrons are being attracted both ways. And if both nuclei can have an effect on that electron, that will hold them together in a bond. All right, so here we go. Here's an example. If the electron is closer to another atom's nucleus than its own, it's ionic. So, here my picture's in the way. Here's an ionic bond. You can see that the electron here from the positive one has been transferred over here. So now we've got a positive ion and we've got a negative ion with an extra electron. This is an ionic bond. The electron goes from one nucleus to the other. Okay? Complete transfer. A covalent bond, on the other hand, you've got the electrons being shared between the two. So they're somewhere in between the middle there. That's the difference between a covalent bond and an ionic bond, is just where are the electrons. So, we talked about electronegativity, the attractions of nucleus. I would have to say that Daniel Craig is probably pretty high on the electronegativity scale because he's pretty attractive. Not as attractive as Sean Connery, but that's the old lady talking. I know you guys think differently these days. All right, so electronegativity is how hard do they pull. So if you've got, here I'm going to zoom again. I did a very good job of spacing these. If you have two nuclei, those are the dots, and they're sharing the electrons equally, meaning that the electrons are going back and forth. They're not more over here, they're not more over there. They're going back and forth between each other. This is a covalent bond. Furthermore, it's what we call nonpolar covalent because everything is shared. There is no area where you have a positive and negative charge. The next kind, still covalent, still being shared, but water molecules are like this. This end has the electron less than this end. This first one's like perfectly shared custody, where the kids are equally split between the two parents. This is where you have shared custody heavier towards one parent. Maybe the mom has the kids all week and the dad just has them on weekends. Or the negative atom has the electrons all week and the positive electron only has them, or positive atom only has them on weekends. But it's not shared equally. This is what we call polar covalent because it makes a pole. Just like if you think about the North Pole and the South Pole, and I'm just going to make a barbershop pole here. Okay, it makes a pole. Now this is a sideways pole. Normally we think about one going up and down. Same difference though. You've got an end that's positive and an end that's negative. Ionic compounds, the electron is given to such a degree that it has no care. It doesn't have anything to do with the positive ion anymore. It's completely surrounding the negative ion. And that's what we call ionic. Ionic bonds are formed because the way I word it at least is the electrons transfer. Here you can see in the picture this electron, sodium has one outer shell electron, and that one outer shell electron goes and moves to the chlorine. Chlorine has 7 outer shell electrons. He needs one more to be happy, so he takes sodiums. That gives sodium a positive charge, chlorine a negative charge. Now, what holds that bond together isn't actually that electron. He's moved, but it's that positive versus that negative attraction. All right, ionic compounds formed from ionic bonds. It's that positive and negative attraction. Usually it's a metal and a nonmetal. Metals form positive ions, which we call cations. Nonmetals form negative ions, which we call anions. The positive ions give their electrons to the negative ions, and you get that bond. They form a crystalline solid. Okay, if you look at the next slide on here, here's a crystalline solid. Okay, they're equally spaced, and really the bond isn't here. There's an attraction here, but there's an attraction here. There's an attraction here. Each of these places has an attraction. So it doesn't make a molecule, it makes a crystal lattice. And that crystal lattice is not a simple molecule. So when we talk about, instead of saying molecules, we talk about formula units, and we use the simplest ratio. For sodium chloride, that simplest ratio is 1:1. If we had magnesium chloride, though, magnesium is in the alkaline earth metal family, so he has 2 electrons he wants to give. Chlorine needs to take 1, which means that magnesium needs 2 chlorines in order to make him happy. And we would write it MgCl2. So that would be the formula unit. That would be the simplest ratio of magnesium and chlorine if we were to look at a crystal lattice of it. All right, interesting thing about ionic compounds. They're very strong attractions because of that positive-negative attraction. They're very hard, they're very brittle. They have very high melting points, so you can heat them up and heat them up and heat them up, and they're not going to melt. But they dissolve in water. Why, you may ask? Well, remember we were talking about polar bonds, polar covalent bonds. Hydrogen and oxygen do not share equally. Oxygen is an electron hog. So this electron from hydrogen gets shared, and the oxygen shares an electron with hydrogen, but they're around the oxygen most of the time. So that makes this end of the oxygen slightly negative, and this end slightly positive. Oh, here, we can put on Mickey Mouse ears. The ears, oh, I got to move my camera. The ears are the hydrogens. The head is the oxygen. So we've got a positive end up here and a negative end down here. And because of that, they surround those salt molecules and start pulling away the positive and negative ions. And we'll talk about that in a little bit. Covalent compounds, on the other hand, are formed when we share electrons and those orbitals overlap. Therefore, those bonds, while they're not as strong as the ionic covalent bond, they're not going to get pulled apart by water that has that positive and negative end, that polar molecule. So they don't dissolve in water. They form molecules. They have weak intermolecular forces. In other words, they can attract to other molecules within the type of compound. They're often flexible and soft, and they have low melting and boiling points.
Ionic bonding occurs between 2 atoms when one of the atoms has sufficient strength of attraction to remove an electron from the other atom. A sodium atom has 1 valence electron, with a stable energy level below containing 8 electrons. A chlorine atom has 7 valence electrons. If the atoms collide with sufficient energy, the chlorine atom will remove the electron from the sodium. The sodium atom loses its only valence electron and becomes a positively charged sodium ion. The energy level below now provides sodium with its stable octet. The extra electron completes a stable octet for chlorine, which becomes a negatively charged chloride ion. Covalent bonding occurs when neither atom has sufficient strength to completely remove the other atom's electrons. The atoms share electrons, and both atoms achieve a stable outer energy level. A hydrogen atom with one valence electron needs one additional electron to complete the first energy level. An oxygen atom has 6 valence electrons and needs 2 additional electrons to complete the second energy level. As the oxygen and hydrogen atoms collide, covalent bonding is accomplished by the sharing of electrons. By sharing an electron pair with the oxygen, the hydrogen completes the noble gas configuration of helium. By sharing with the hydrogen atom, the oxygen atom now has 7 electrons in its energy level, still one short of the stable octet condition. A stable octet for oxygen can be completed by sharing an electron with another hydrogen atom.